Hello, mathematicians, and we are on page 13 of our Unit 6 packet. In your packet might say day 6, but this is actually day 7. We are presented with a word problem. Therefore, we're going to read, reread, and annotate before we begin. So I'll read it once. A rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by h of t equals negative 16t squared plus 64t plus 80, where t is the time in seconds and h is the height in feet. All right, I'm going to read it again, but this time I'm going to highlight. I'm just going to underline in this case. And it says, a rocket carrying a fireworks is launched from a hill 80 feet above the lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface lake is given by h of t equals negative 16t squared minus 64t plus 80, where t is the time in seconds and h is the height in feet. Now that I read it twice, looking at this, I'm definitely going to want to circle, or I boxed, the equation that it gave me. I might want to note that it's a quadratic. Okay. Other things that I might want to make sure I highlight is t is time in seconds and h is the height in feet. And actually our first question says, what does t represent? Well, t represents time in seconds. And the next question, B, says, what does h of t represents? And that represents the height in feet. What is the input of the function? Well, the input here would be time, right? Remember, inputs are independent variables, things that we can't change. We can't change time. And what is the output of the function? Well, here would be h of t, right? These are things that are dependent. So the height is dependent on the time. Now I'm going to move this up a little bit. Okay. And it says, how long will it take the rocket to reach 128 feet? Well, we're going to have to use the equation that was given to us. Which was h of t is equal to negative 16t squared plus 64t plus 80. So if we want to know when it reaches 128 feet, well, here they're talking about the height. So now I'm going to replace h of t with 128. So if 128 equals negative 16t squared plus 64t plus 80, and if they're asking us how long will it take, well, clearly they're asking us to find t. So in order to that, it's me solving the quadratic. And we know for the first step is that our quadratic has to be equal to 0. So I'm going to subtract 128 from both sides. And here they'll cross out. I'm going to have 0 equals negative 16t squared plus 64t minus 48. Well, now that's equal to 0, I can start looking at my factoring methods, and I could see that negative 16, 64, negative 48 all have a GCF of negative 16. And the reason why I'm taking out the negative is that when we are solving, we really don't want to work with a negative t squared. So I'm going to pull that out. Okay, and then we are left with t squared minus 4t plus 3. And then I could use the Xbox method. And when doing so, I would have 3 on top and negative 4. And the factors here would be negative 1 and negative 3. And once I do that, I would be left with negative 16 t minus 1 t minus 3. And I'm saying this whole thing equal to 0. I definitely need more space, so hold on. I move that here. And now let me bring what I just wrote on top here. Right, so I'm coming back up here. So negative 16 t minus 1 t minus 3 equals 0. I can make my t chart, and I would have t minus 1 equals 0, t minus 3 equals 0, and I would even have, it's a weird t chart, but I wouldn't have negative just trying to make some space. I would even have negative 16 equals 0, which we know is not true, so that would just be rejected. And then here, to solve for t, plus 1 to both sides. Here I'd plus 3. And I would have t equals 1 and t equals 3. Now, we have 2 answers. And in this scenario, it does make sense. If you're thinking about this, right? The rocket's going to start at 80 feet, right? It's going to go up. Eventually, it's going to hit its peak and it's going to come down. Right over here. Okay, that's 128 feet. There's going to be 2 times where it hits it. So we could say that after 1 second and again after 3 seconds, okay? All right, let's go down to F and E. So F says find the height at 0 seconds. So if they're telling us the seconds, that means they're giving us t. So h of 0 is equal to negative 16 times 0 squared plus 64 times 0 plus 80. Okay, we go back to our original. And here we could say h of 0 equals, now you could put this whole thing into your bestie, just like it's written. And then you would have equals 80, and the units here would be feet. And then it says, what is the graphic name of this point? Well, if you think about this point, it's 0, 80, and that it's the y-intercept. Okay, the y-intercept is where this equation is crossing the y-axis. It's actually its starting point. Okay, and if you go back into the problem, the first line says a rocket carrying a firework is launched from a hill at 80 feet above the lake. It's exactly where it's starting from. All right. G, find the height at 2 seconds. All right, again, they're giving us the t, the time. So h of 2 equals negative 16 times 2 squared plus 64 times 2 plus 80. Again, enter this whole thing into your bestie, and you have h of 2 equals 144, and the units here are feet. All right, thank you.